Alrighty, so we left off talking about compound interest, which is it's the interest paid on the principal plus interest that you have done previously, which is going to be called the compound interest. So after a certain period of time, the interest earned so far is called the credited or the added to the account. And the sum for the principal plus the interest earns during the next series of next period. So basically in a compound interest, it could be monthly, annually, quarterly. So it could be adding on at a different compound. Now, the compounding period, it can be credited to an account at terms of intervals other than 1 year. So it could be done semi-annually, quarterly, monthly, or daily. The period of intervals, it's called the compound period or the period of compound. So the compound is the compounding period is how many times is it going to be compounded? Now let's look at this example. So when we're looking for the future value for compound interest, if P dollars are deposited at an annual interest rate of R compounded N times per year, and the money is locked in the deposit for M period of time, where T becomes N over N years, then the future value of A is using this formula, which is A of 1 plus R over M all raised to the M, or A is equal to P 1 plus R over N NT. So most of the time we are going to be using this one because M, if you look at T equal M over N, well, how do we solve for M? We multiply both sides by N, so NT is M. So they're pretty much the same. You're just solving for one of the variables. So we're going to be using this formula throughout. This is for compound, and N is how the compound period. So the variable N is the compound period. So N is going to change depending. So let's look at this one. Find the future value of $8,560 at 4% compounded quarterly for 8 years. So we have N, the period, to be quarterly. So if it's quarterly, it's going to be 4. The value of P is 8,560. The rate is 0.04 and T is 8 years. So we're going to use the formula from above. So we're going to say, well, A, the future value is P, which is 85,060 times 1 plus R, my rate is 0.04 over N is 4 raised to the NT, so 4 times 8. So this should be 32. So I'm going to use this and I'm going to plug this on my calculator to give me the answer. So again, I'm going to project my calculate 84. That will help me out and to solve. So I'm going to go ahead and share my screen here in a moment. There it is. So I'm going to clear everything and I'm going to put 8,560 parentheses 1 plus, I'm going to do 0.04 divided by parentheses 4, close parentheses, open another parentheses, all that value raised to the 30. Oops. So I'm going to put parentheses and then I'm going to do this little hat, this little like caret, and I'm going to raise that to 32. And that should give me 11,759.49. So if I'm going to share my screen here, when I plug that in my calculator, I get 11,769.49. So this is the future value for my compound interest quarterly. So let's write that down. So quarterly after 8 years. Because we need to make sure that we understand where is this coming from. Now, what if we're finding the present value for my compound interest. Now you know what A is, you're finding P. So now this is your value of A, 18,000. So it's 18,000 to be A. 5% is my rate. Rate is 0.05. Compounded monthly, N is 12 because it's monthly if and T is 20. Now I don't know what the value of P is. So I'm going to do P 1 plus R over N NT. So now let's plug it in. We don't know what P is, but we know what R and N is. So it's 0.05 over 12 times 12 times 20. 12 monthly, 20 the year, NT. And then here we have 18,000. If we want to solve for P, well, we need to divide everything out. So I'm going to put it over here. It's going to be P is equal to 18,000 divided by 1 plus 0.05 over 12, all raised to, well, what's 20 times 12? Well, 2 times 12 is 24, add a 0, 240. So I'm going to punch this on my calculator to see what I get. So making sure that I always need to use parentheses. So let me clear everything. So I'm going to have 18,000 divided by parentheses 1 plus parentheses 0.05 divided by 12 close parentheses. Raise that parentheses to 240. And that should give me my principal amount to be 6,635.60. So let's see if that's true. So once it's calculated there, let's check our answer. So our solution should be 6,635.60, which it matches what we have. Now, moving on to effective annual yield. What does that mean? So when you're looking at an effective annual yield, you're looking at savings institutions often give you two quantities when advertising the rates. The first one is the actual annualized interest rate is the nominal rate, which is the stated rate. The second quantity is the equivalent that will produce the same value at the end of the first year. So when you're the same final value or future value at the end of the first year, when the interest is being paid, where the simple rather than compound. So the effective rate yields to the effective annual yield. So it's the value you pay after the year of interest. So we're going to use this formula. So the nominal interest rate of R compounded n times per year is equivalent for the following effective annual yields. So depending on how much it's compounded, that's how much interest you're going to pay. So this effective annual yield have the formula y equal 1 plus R over n raised to the n minus 1. So we will use this to find the nominal interest rate of R. So there it is. So we're looking for what is the effective annual yield of an account paying at a nominal rate. So the rate is 4.2% or 0.042. And it's n compounded monthly. If it's monthly, well then n is 12. So we're going to use y is 1 plus R over n raised to the n minus 1. So that's going to be 1 plus 0.042 over 12 raised to the 12 minus 1. And that is how much is going to be the effective annual yield. So let's punch this on the calculator. Let me go ahead and share my screen here. So there it is. I'm going to clear everything out. And then I'll have parentheses 1 plus 0.042 divided by 12, close parentheses, all the parentheses raised to the 12, close parentheses, minus 1. And that should be equal to 0.0428. So this is going to be 0.04281. So if I move it over, that's 4.28%. So I'm going to go ahead and share my screen and see if what we calculated was correct. So there it is. We punched this on our calculator and we got 4.28%. So this is going to be the effective annual yield for this account. So when we're talking about inflation, so in terms of an equivalent number of goods or services that it's given in the amount of money you buy, it's probably going to be more today than later. So inflation will change. We'll see that in prices and food. Inflation has grown so much. Prices of homes, prices of food, prices of gas, things that kind of fluctuate here and there. So the periodic increase in the cost is called price inflation. Unlike other values under interest compounded, which makes sudden jumps in time, price levels will tend to fluctuate gradually over time. So there exists a formula for a continuous compound. So inflation is an estimate of a compounded that's continuous. So inflation in an economy usually is presented as a monthly or annual prices estimated by the government. So who talks about that, who manipulates what is going to be the price is the government, provided by the United States, the Bureau of Labor Statistics, that publishes the Consumer Price Index. So this Consumer Price Index reflects the prices of certain items purchased by large numbers of people. So there's probably like a list that will change on a monthly basis or an annual basis. So we have future values for continuous compound. So exists something that is continuous. So if an initial deposit of P dollars earns continuously compound interest at the annual rate of R for a period number of T years, then the future value of A is calculated as A equals P E raised to the RT. E is a natural number. It's called a transcendental, which is 2.723, so on and so forth. This goes on forever. But your calculator has this E number. You don't have to memorize it. You just have to plug it in on your calculator, where R is the rate and T is the time. So the time in years. So let's look at this one. Suppose you want to find the future value for a continuous compound. Suppose that a cup of favorite coffee is $1.25. If the inflation rate persists over 2% of the time, what's going to be the price after 25 years? So we know that A is PERT, where the P is $1.25. E, it's going to be the number that it's going to be on your calculator, but that's going to be multiplied by 0.02. 2% changes to 0.02 times 25. And then we're going to get approximately the price of that coffee after 25 years. So let me punch my calculator. So I'm going to clear this out and I'm going to do $1.25, close it. And then you have this E. This E is like below the N, so second E. So there's this E and then there's this E to the XE. So second E, which are both the same. I'm going to use parentheses, 0.02, close the parentheses, times 25, close parentheses. And that should cost me about $2.06. So it should be 125 times E to the 0.02 times 25. And I'm roughly going to get $2.60 or $2.06. So there's a typo on the note, so let's change it. So the typo, it has 225, but we actually started with 125. So that's a typo. So the actual cost will be, $2.06. So finding that, so there's a typo right there. So remove the $2.25 because that was in our principal. The principal amount was $1.25, not $2.25. Or otherwise it will change, of course. Let's talk about inflation proportion. There exists something called the inflation proportion. So for a consumer product or service subject to average inflation, prices in 2 different years are calculated as follows. So the price in year A over the price in year B is equal to the CPI. Well, what's CPI? Remember, Consumer Price Index. That's what's CPI. So we're going to look at the actual price compared to the price that the CPI puts on it. So there's 2 ratios, the ratio of the price a year and the CPI in year A and over year B. So let's look at this example. Looking at the comparison of a tuition increase to average inflation. So if your mother paid $3,000 in tuition in 1980, at the same college you will be attending paying $9,300 in 2005. Compare the school's tuition increase over the same period. So let's look at this. We're going to look over the price in the year in the 2005 over the price in years in 1980 is equal to the CPI in year 2005 over the year in the CPI of 1980. So we have $3,000 and $9,000. So the price is 9,300 over 3,000, right? That's how much it's going to be. If you're comparing the inflation, right, you're going to have the price here, the price of 2005, there it is, the price of 2005. This is how much you're paying. And this is the tuition versus this is how much you paid in tuition back in 1980. So we're going to create a proportion. So we don't know the value for the actual tuition in 2005. So we're going to create a proportion between X over 3,000 because the $3,000 is how much she paid in 1980 is equal to 195.3 over 82. So where did they get this number? So the number that they got was actually by dividing the $3,000 and the 1980 and 9,300 in 2005. So then we have X over 3,000. We multiply across, and we're going to get that the actual price is 7,100.44. Now, how does this compare to the actual tuition? Well, the actual tuition is 9,300, and the other tuition is the projected is 7,110.44. So that means that the tuition at the school increase is approximately, so if this was 100%, you add 31% more. So there's approximately 31% more than the CPU average. Okay. So similarly, when you are comparing a tuition over an increased average inflation, an estimate of years to double, which is the number it takes for the general prices to double for a given year, is given by this example. So by this formula. So years to double, approximately it's 7 over the annual inflation. So using this formula, we want to estimate the number of years to double for an annual inflation rate is 2.1%. So there is the annual inflation. So it's 70 over 2.1. We don't have to change it to a decimal. We leave it as a percent. So we will have 70 over 2.1 would be roughly 33.33 this should be rounded in years, which is going to be 34 years. So with an inflation rate of 2.1%, prices would double in about 34 years. And that finalizes our lecture notes for the section 13.1. So just to review a little bit, making sure you look at the price in 2005 over the price in 1980. So if we take the 9,000, so let's do that, 9,300 over 3,000, that gives us 31. Oh, sorry, 3,000. It gives us 3.1. So without having to do a lot, you can just use the fact that when you take your 9,300 over 3,000, it's going to give you, so it's going to give you 3.1. So this 3.1, if we divide it by 10, because of the years, this is 0.31. So this takes you back to your 31% more than the other. So that is another way to solve it. We will see more solutions of this nature. So hopefully this made sense. Otherwise, let me know. I will go ahead and publish it, and then we will talk about section 13.2.